Hello students, in this video we will see 114 marks. We are going to solve second 7 mark at first. This questions comes under simulation type. There is one production line that is producing trucks, and there is a fluctuations of production per day of that particular company, and they have also given the probability of the production per day. For an example, the probability of producing 45 trucks per day is 0.03. Similarly, they have given the range of production per day from 45 to 55. With the use of random numbers, we have to simulate the number of waiting trucks in the factory for the first 10 days, and also we have to evaluate the average number of trucks waiting in a factory, and also we have to find the average number of empty space on the train. So for that, we will write the production and probability as they given, and we will find the cumulative probability by adding the previous probability to the current probability. So for the first thing, we will have only 0.03, but for the second thing, 0.03 will be added to the 0.05, and we will get the cumulative probability as 0.08. Similarly, we will add 0.08 to 0.05, and we will get 0.15. Likewise, we will do till the end. At the end, we will make sure that you will have 1 as a last probability. And also with this cumulative probability, we have to write the range of the random numbers. So we will not include this 03 in this range as we discussed before. We will write only 00 to 02. This 03 will be included in the next range, and this 08 will not be included in this range. Similarly, we have to write the range of random numbers till the end, and we will not have 100 as a 100 in that particular ranges. So after that, we have to simulate for 10 days. So I will write days count, and for the days count, the given random numbers are written, and with that particular random number and with this range, we have to find the expected production. For example, the given first random number is 37. This 37 will comes under this range. This range is belong to the 49. So here I will write the expected production as 49. Similarly, for 35 belongs to the same range, so the expected production will be 49. For an example, 95, this 95 will comes under this range, and the expected production will be 54. This is how we will write this expected production. With this, and the train capacity is 51, we can write the number of trucks waiting to transport. Here the first day production is 49, the train capacity is 51, so that no trains will be waited at the industry, and there will be 2 empty spaces on the train. Similarly, if for the third day they are producing 51 trains, the capacity of a train is 51, so there will be no train will be waited, and there is no space for truck in the particular train at that particular day. So similarly, we will find number of trucks waiting on that particular day, and the number of empty spaces on that particular train. And they are asked us to find the average number of trucks waiting in a factory. We will add the number of trucks waiting in a factory here. It will give 3, and if it is divided by 10, since the number of days is 10, we will get 0.3 trucks per day. Similarly, we have to find the average empty spaces on the train. So total empty spaces will be getting from here, and the total empty space is 13 for the next 10 days. So our expected average empty spaces on the train is 1.3 spaces per day. That's all. So this is how we will solve the simulation problem. The steps are production probability. You have to find cumulative probability. With that cumulative probability, you have to find the range of random numbers, and we will take some random numbers according to the question. With that random numbers and range of random numbers, we will define the expected production. With that production, according to the question, we will solve the question. That's all. In our second question, there is one company. That company has 4 salesmen A, B, C, D and the 4 counters PQRS. We have to find each salesman can handle any counter. We have to assign the work salesman to the counter. So this problems comes under assignment problem. We have to assign the salesman and counters, and also we have to assess the total service time. For this, we will find we have to write the cost matrix they have given. So I have written like this A, B, C, D and PQRS. And first step, we will do row reduction. For that, we will take the minimum from each rows and we will subtract that particular number in the corresponding rows. For an example, in the first row 22 is the minimum value and I will subtract that 22 from all these elements. Similarly, we will do this for 4 rows. After this, we will do the column reduction. Similarly, you have to take the minimum values from each column and have to subtract from each elements of that particular column. So here, for an example, in this last matrix, in first column I have 6 as a minimum value and I will subtract 6 from all the elements. I will get 2, 0, 4, 0. Similarly, I will do this for all the columns. After this, we have to cover all the zeros with a minimum number of lines. As I drawn here, we have some 7 to 9 zeros, and I am covering all the zeros with the 3 lines. I can cover these with 4 lines also, but you have to cover all the zeros with a minimum number of, it can be maybe horizontal lines or vertical lines. If you are sure about you have covered all the lines with the minimum number of lines, you have to compare with that the number of rows present in that cost matrix. In our cost matrix, we have 4 rows. Still, the number of lines we have drawn is less than 4. This is not an optimal matrix, so we have to develop a new matrix. To develop a new matrix, we have to pick the smallest uncovered value. So smallest uncovered value will be present here. Smallest uncovered value is 2. So with this 2, we will do 2 actions. One is we will subtract 2 from uncovered values. So we will subtract 2 from these 6 values and we will add that 2 to all the elements that are in the intersection of the lines. So we will add 2 here. So we will subtract 2 in this all 6 elements and we will add 2 in the intersection of the lines. So we will get new matrix. So with this new matrix, if I try to cover this, I can cover with a minimum number of lines, that is 4. So our number of rows are also 4. So this is the optimal matrix. From this matrix, we can assign the salesmen to the counter. So I am assigning A to P. So this will not be available for anyone. And also I am assigning B to R, so that this will not be available for anyone. Similarly, I will assign C to S. So this will not be available for anyone. Similarly, I will assign D for Q. So this is how we will assign some salesmen to the counters. Since this is the only optimal solution, we have these assignments, and our optimal assignment will be same as we have assigned, and that minimum service time will be the time for the service time for A 30 hours, the service time for B is 11 hours, the service time for C is 18 hours, and service time for D is 23 hours for the counters PQRS, P or SQ respectively. So we will add these 4 and we will get 82. So this is how we will find the total minimum service time. You have to find the total minimum service time from the optimal assignment only, not that any assignment, not from that any assignment. Thank you.